Okay guys, here we go. It's our very first video lesson, Unit 1, Lesson 1. Remember, SWBAT stands for Students Will Be Able To. So by the end of the lesson, you should be able to identify whole, integer, and rational numbers. And we'll talk about what those three are. But our goal is to be able to look at a number and decide if it is a whole, an integer, or a rational number. I've got two vocabulary words for you, and don't forget, on your vocabulary, you need to put those in your flashcard app on your iPad. First vocabulary word, an integer. That's any real number that's contained in an infinite meaning goes on forever, set of numbers such as -3, -2, -1, 0, 1, 2, or 3. So if we look at those numbers, we see that it includes the whole positive numbers like 1, 2, and 3, but it also includes the negative whole numbers, -3, -2, -1. So it includes all the whole numbers, 1, 2, and 3, and we call those opposites. They're negative counterparts. But we aren't going to include any decimals or any fractions in our integers. Now if we go to our rational number, that's going to be any number that can be written as a ratio or a fraction where the denominator cannot be 0. So any number that can be written as a fraction. We also are going to include terminating decimals and repeating decimals in our rational numbers, and we'll take a look at those here in a minute. This page that you're seeing here is going to be a huge help as we go through these couple lessons. This is in your reference section on the Moodle page, so you can pull this up at any time and look at it. In this, if you take a look at the middle of our page, you're going to see the whole numbers. Those whole numbers, again, those are numbers like the counting numbers, 1, 2, 3, any number that is a positive number and does not include a decimal, a fraction, has to be just a whole number. Now if we take a look at our next circle, here's going to be our integers. This is going to include the whole numbers because the whole numbers are within our circle of integers, but now we're also including the opposites of the whole numbers, those negative numbers, -7, -9, -5. The negative whole numbers as well as the positives. So if it's a positive or a negative whole number, it's going to be an integer. If we go outside here and look at the rational numbers, now we're still including the whole numbers because that's in the middle. We also are still including the integers because it's within our rational number circle, but we're including these things on the outside that were not in the integers or the whole numbers. Things like 0.5. We call 0.5 a terminating decimal. 2/3, that's going to be a fraction. 0.33333 repeating. That's a repeating decimal. Any of the repeating decimals, terminating decimals, or fractions can all be included now in the rational numbers. Now if I were to ask you, is 2/3 an integer? You would say no because it's outside the integer circle. Okay, if I were to ask you, is 0.5 an integer? No, it's outside the integer circle. But it is a rational number because it's within the rational number circle. All right, and we're going to also look at how 0.333 or 3 repeating and 0.5, how those can be written as fractions. So the overall rule for rational numbers is, can it be written as a fraction? If it can, then yes, it is a rational number. Okay, let's move on here. All right, let's first of all take a look at integers. We can write situations or phrases as integers, and we can also graph those on number lines. A lot of you guys are playing football right now. If you were to have a loss of 10 yards, that would mean that you started at a point and you fell back 10 yards. We're going to depict that as a -10. A loss of 10 yards would be -10. Okay, so if we were graphing this on our number line, we would place that middle point as 0 and our point back here as -10. This is where you would be. Now let's take a look at the next one. I withdrew, there's a key word, $100 from my bank account. By withdrawing, it means that I had a certain amount and I took some away. So now I'm back here at -$100. So if I were to graph that, it'd be 0, -100. We'd plot our point right there at -100. To withdraw $100 means to have a -$100. Okay, 3, the city was 300 feet above sea level. Well, if we're drawing our number line first, this would be sea level. So that's 0. It's kind of our baseline. And to go 300 feet above that, that'd be over here. We'd be in the positive section, 300 feet above sea level. So this would be our point we'd be plotting, and our answer would be a positive 300. Now let's take a look at some rational numbers examples. Remember that a rational number can be written as a fraction, a terminating decimal, or a repeating decimal. And I'll show you how terminating decimals and repeating decimals, we can turn those into fractions too. But 2/3 is definitely going to be a rational number because it can only be written as a fraction. So this is going to be rational. Now let's look at 0.5. 0.5, when we say that, we say 5/10, and we can write it the exact same way. 5/10 is a fraction. If we were to reduce this a little bit or simplify it, we could divide the top by 2, divide the bottom by 2. Oh, I'm sorry. Divide the top by 5, divide the bottom by 5. I was one step ahead of myself. And we're going to end up with 1/2. So if I were to look at 0.5, I could call that 5/10, simplify it to 1/2, and then I would still be able to see that, yes, this is a rational number because it can be written as a fraction. Now let's look at 0.4 repeating. This is probably the toughest one we're going to run into today. 0.4 repeating. Anytime you see any single digit number that repeats, such as 0.3 repeating, 0.6 repeating, that's because that as a fraction would be represented as 4/9. And let me show you why that works. If I take 4 and divide it by 9. Well, I can't take a 9 out of 4. I don't have enough. So I'm going to go ahead and put a decimal point and add a 0. 9 now divided by 40 would be 4. I can get 4 9s out of 40. And whenever I do my multiplication and subtract, my remainder is going to be 4. So I can bring down another 0. Okay, I'm starting to see a pattern here. 40, how many 9s can I get in 40? Well, I can get 4. So 36, and again, I would get a 4 as my remainder, and you're going to see that pattern go on and on and on and on. So our answer here would be 0.4444, and we just call that 0.4, and we put a repeating sign over the top. So what I'm trying to get across to you is any single digit number that repeats is going to be equal to that number over 9 as a fraction. So here we'd have 3/9 is the same as 0.3 repeating. 6/9 is the same as 0.6 repeating. All right, let's take a look at some examples. We want to look at 0.8, 105, -19, 0.787878 or 0.78 repeating, and 10/5, and decide which sets they belong to. Well, let's start by looking at 0.8. Is it a whole number? No, because it has a partial to it. It's 0.8 of a whole number. Is it an integer? No, again, an integer also has to be a whole number, but it can also be a negative whole number. Is it a rational number? Yes, that's the only place that 0.8 is going to fit in here. All right, let's look at 105. Is it a whole number? Yes, it is. It fits in that whole number circle. Is it an integer? Yes, because remember, all of the whole numbers are integers, so we're going to include 105 as an integer. Is it a rational number? Again, the whole numbers and the integers are within the rational number circle, so we're going to include that there too. Let's take a look at -19. Is it a whole number? No, because all of the whole numbers have to be positive. So -19 is going to fall right. Oh, sorry, -19 is not a whole number. So we can't put it there, but we can put it with the integers because -19 is a whole number that is just a negative. And then remember, is it a rational number? It sure is because all of the integers are rational numbers. All right, let's look at 0.78, or what is approximately 0.78 with a repeating sign over the top. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, because it's a decimal that repeats. So we're going to add that guy to our list. And now 10/5. 10/5 is the same as 2. So is 2 a whole number? It sure is. Is 2 an integer? Yes, because all of the whole numbers are integers. And is 2 a rational number? Yes, because all of the whole numbers and the integers are rational numbers. And finally, because our definition of rational number says any number that we can write as a fraction, we're going to show how these are rational numbers. So we're going to take the following and we're going to simplify them and then state which number set they belong to. So when I simplify 0.45, I would call that 45 hundredths. So I can just write that as 45 hundredths. 45 hundredths, when I simplify it, I can divide the top by 5. I can divide the bottom by 5. When I do that, I'm going to get a 9 on top and a 20 on bottom. That's as simple as I can get. So I've simplified the fraction. Now, I need to say what set that belongs to. Is it an integer? No, because it's not a whole number. It's not an integer. Is it a rational number? It sure is. So we're going to put an R there. Okay, 5. It tells me I have to write it as a fraction. Well, if I'm going to write 5 as a fraction, I can always make any whole number a fraction by putting it over 1. So, is this a whole number? Yes. Are all the whole numbers integers? Yes. Is it a rational number? Yes, because all the whole numbers are rational numbers. So we'd have whole, integer, and rational. Okay, now we're looking at 101 thousandths. So I'm going to write it just like that. 101 thousandths. Now, I can't simplify that because 101 is a prime number. So that means nothing can divide into it. So 101 and 1000 have no common factors. So we're going to leave that just how it is. So is 101 thousandths a whole number? No. Is it an integer? No, because it's not a whole number, it's a partial, but it is a rational number because I can write it as a fraction.